Hey everybody, Mr. Sanford here with your next video for you. So we're talking about dilutions today. It's a process where we take a known concentration of a solution and it is decreased. That concentration is decreased by adding solvent, usually water. So that known concentration solution is usually called a stock solution. This is a common means of preparing solutions of a desired concentration. So we oftentimes need to dilute things to our liking. They're performed by obtaining a solution of known concentration, that's stock solution, measuring the volume of that stock solution before we add any solvent, and then adding a very specific amount of solvent, usually water, to reach that desired concentration. So we're going to use a formula to figure out what that concentration or volume for the desired solution could be. So M1V1 equals M2V2. M1 is the molarity of the stock solution. That's stuff we're working with. V1 is the volume of the stock solution that we're going to use, and we're going to dilute it, right? M2 is going to be the molarity of the diluted solution, and V2 is going to be the total volume of the diluted solution. So this one gets a little tricky sometimes. Make sure you understand that V2 is the total volume of both solutions together. So here's an idea for you, right? We got 0.850 liters of 5 molar solution of copper nitrate. We're going to dilute it all the way to a volume of 1.8 liters. What is the new molarity? Right? So we list the things we know. They tell us that the stock solution was 5 molar. We had 0.85 liters of it. And we're going to dilute it to a new volume of 1.80 liters. What is the new concentration? That's our question mark, the new molarity. So we're going to use our formula M1V1 equals M2V2. We're trying to get M2 by itself. So let's divide both sides by V2, cross it off on the right side, and get a new formula. So our new molarity equals M1V1 over V2. Let's plug in our values that we just listed on the left. So M1 was 5 molar, V1 was 0.85 liters. We're going to divide that by the new volume, or the final volume, or the total volume, 1.80 liters. So we do the multiplication first, and then the division, and we're going to find out that equals 2.36 molar. So if we were to take this 0.85 liters of 5 molar copper nitrate and dilute it with water up to 1.8 liters, the new molarity would be 2.36. Here's what we do for you, another example. So we want to figure out what volume of 0.12 molar HBr that we can prepare if we have 11 milliliters of 0.45 molar HBr. Right? So let's list what we know. They tell us that we're starting off with 0.45 molar HBr, and we got 11 milliliters of it. And we know the concentration that we're trying to get it to is 0.12 molar. So we got to figure out how much of that we can make if we have these things. So use our same formula, M1V1 equals M2V2. This time we're trying to find V2. So let's get rid of M2 on both sides. Divide by M2 on both sides. Cross out M2 on the right. V2 is going to be M1V1 over M2. Let's plug in what we know. The original concentration is 0.45 molar of the stock solution. We have 11 milliliters of it, and we're going to dilute it to until it has a concentration, a new concentration, M2 of 0.12 molar. So the volume of HBr at 0.12 molar that's going to make is 41 milliliters. Right? So we do the multiplication first and then the division. And we get 41 milliliters. Here's another redo. So we want to figure out how we should prepare 500 milliliters of 2 molar HCl from 6 molar stock solution of HCl. So let's list what we know first. We're trying to get 500 milliliters. So that's our new volume. And we want those 500 milliliters to have a concentration of 2 molar. And then we know we're starting off with a 6 molar stock solution. So that's M1. And we got to figure out how much of that we're going to dilute to 500 milliliters. So we want that initial volume of our stock solution. So use our same formula, our dilution formula. M1V1 equals M2V2. We're trying to get V1 by itself. So let's divide both sides by M1. Cancel on the left. V1 equals M2V2 over M1. Plug in the numbers we just listed. V1 equals 2 molar. So that's M2. The second molarity, 2 molar times that new volume we want. The diluted volume is 500 milliliters divided by the stock solution concentration, M1, was 6 molar. Multiply first, then divide, and we get 170 milliliters. So this is telling us we need to take 170 milliliters of 6 molar HCl, and if we dilute it with water until it's 500 milliliters, it'll have a concentration of 2 molar. There are 2 you-dos on your paper there. I want you to pause now and try those out. The answers are here for you to check your work. Pause. All right, we're back. So we're going to make some solutions here and compare concentrations after we do some dilutions. So let's talk about volumetric flasks and how we're going to make these solutions. So the first thing you're going to do is take your stock solution, which is 2 molar red. It's right there for you. And we're going to measure with a graduated cylinder first and add it to a volumetric flask. So this is a volumetric flask, this bell-shaped thing. It only has one line. The graduated cylinder is a straight column and has all kinds of lines on it, right? So use a graduated cylinder to measure the stock solution and then pour it in here. And then we're going to continue to add solvent, water, this time, until you near the fill line mark. This line right here, the only line on the volumetric flask. When you get close, you stop and you use a pipette or a dropper to fill it all the way to the line. You want to get as precise as possible. Make sure you measure to the bottom of that meniscus. So solution 1 that you need to prepare, first thing we want to do is know that we want it to be 100 milliliters because that's the size of the flask. And we want it to be a 1 molar red solution. And we're starting with 2 molar stock solution. So we need to do some calculations and then we'll talk about procedures here. So we know that the total volume is going to be 100 milliliters. And we know we want that 100 milliliters to be a 1 molar concentration. And we know we're starting with 2 molar concentration, right? So the stock solution comes before, right? And then what we're going to dilute it to is the M2 and V2. And so what we got to figure out is how much stock solution to measure out and then dilute, right? So we use our formula. M1 V1 equals M2 V2. We're trying to find V1 that's isolated. Divide both sides by M1, cross off on the left, get a new formula, plug in some values. M2 is 1 molar, V2 is 100 milliliters, divided by that original stock solution concentration, 2 molar, right? Do the multiplication, then the division, we get 50 milliliters. So the procedure for making this, the first thing you're going to do is measure out 50 milliliters of 2 molar stock solution, which is red, in the graduated cylinder. Then you're going to add it to the volumetric flask. You're going to pour it in there. And then you're going to use water in the volumetric flask to get to the 100 milliliter fill line, right? Use the dropper. Stop early, don't go over, and then use the dropper to get as close as you can. Solution 2. Now we want to make a solution that's 0.5 molar red solution. So we're starting with the same stock solution. We want it to be the same volume, 100 milliliters, but we want a new concentration this time. So let's list what we know. We want it to be 100 milliliters. We want it to be 0.5 molar. That's our new stuff. That's after the dilution. And we're starting with 2 molar stock solution. So we got to figure out how much of that to dilute up to 100 milliliters to get this concentration. So use our formula. M1 V1 equals M2 V2. Divide both sides by M1. Cancel on the left. We get a new formula, M2 V2 over M1. Plug in our values. This time 0.5 molar is our new concentration we want. And it's going to be 100 milliliters in that flask. And we're starting with 2 molar solution. So multiply and then divide, and we get 25 milliliters this time. So the procedure is going to be very similar. The first thing we're going to do is measure out 25 milliliters of that 2 molar stock solution with a graduated cylinder, and then pour it into the volumetric flask. Then we're going to add water until we get close to 100 milliliter mark, and then stop and use a dropper to add the rest. Third solution. We want to prepare another 100 milliliters this time of 0.1 molar red solution. So a much, much smaller molarity or concentration. We're still starting with that 2 molar stock solution. So let's talk about our calculations. We know we wanted to dilute it to 100 milliliters. We know we want the new concentration to be 0.1 molar. And we know we're starting with the same stock solution, 2 molar. We got to figure out how much of that 2 molar stock solution to dilute to 100 milliliters. Same formula, same calculation. Isolate V1. Plug in the numbers we want. Our new concentration is 0.1 molar. We know we're going to dilute it to 100 milliliters, and we're going to divide by the original concentration. So multiply first, then divide. Our volume is going to equal 5 milliliters. So we're going to measure out 5 milliliters of our 2 molar stock solution with a graduated cylinder. Add it to the volumetric flask. Pour water until we get close to the fill line, and then use a dropper to fill it to exactly 100 milliliters. At this point, I'd like you to stop. Each of those you should have poured into one of the plastic cups. or paper cups on your desk. If all of it doesn't fit, that's fine. Just make sure you get some in the paper cup. And then we're going to compare the color of each one. So I want you to pause. You're going to make those solutions, pour a sample of each one into a different paper cup. If you have leftovers, just pour it down the drain in one of the sinks, and then make some observations and do some analysis and come back and check your answers. So pause now, lab time, come back to check. All right, we're back. So your observations. After you made all three solutions, you were supposed to compare the color of each one to the stock solution. Which one is darkest and which one is lightest? Turns out the stock solution was the darkest, and the third solution, 0.1 molar, was the lightest. So that's what we should have seen. So why does that happen? Let's explain the relationship between molarity and color. So we should have seen that if the molarity increased, so did the darkness of the color. So the greater the molarity, the more concentrated the color is, right? So as molarity increases, we know that those colored particles are increasing, and so it should appear darker. And vice versa, if the molarity is decreasing, that means we have less particles, so the color should get lighter. Question 2, you're asked to create a particle model to represent the relative concentrations of each solution. So stock solution all the way down to your third solution. So your stock solution was the darkest. It should have had the highest concentration, 2 molar, and it should have the most colored particles, so a lot of them in there. And then it should decrease as we continue to decrease the concentration, right? All the way down to this 0.1 molar solution, which has the lightest color and the lowest concentration. So there's some error here that we can talk about. So 1, explain how the concentration of the solution would be affected if water was added past the fill line, like if you were being careless and accidentally added too much water in the volumetric flask. So if that happens, that means the concentration will be lower. The additional water dilutes the solution, so it decreases the concentration. And finally, what would happen to the solution, or the concentration of the solution, if some of the stock solution remained in the graduating cylinder and wasn't completely transferred to the volumetric flask? Well, that would mean there would be a lower concentration in the volumetric flask, right? So it would be lower than it's supposed to be. So there would be fewer of those colored particles or moles of the solute in the new solution. So you diluted less, so to the same volume, so the concentration would be lower.